Alright, let's just go through this. Oh, this is, we'll put a part A next to it, because I'm giving you two parts. I just gave you the second part today to work on. So let's just go through these as quickly as we can. Alright, this problem says, write the expression in lowest terms, or just simplify it. So if you look at this, you can't cancel anything out because you get this plus sign in the middle. So really, the only thing that you can do right here is factor the top and the bottom. Alright, so let's everybody look up here. Look at the top. We need to factor the top. What is the largest number that divides into both of these numbers right here? 9 and 36. 9 does, okay? So we factor out a 9, and when we factor it out, we're dividing a 9 by everything here. So if I divide this by a 9, I get an x, and 36 divided by 9 is a 4. Alright, easy as that. Look at the next part. Look at the bottom. Let's factor that as well. So we factor out a 5, and we factor out a 5, we get x plus 4. Now that works out real nice. It's kind of rigged, isn't it? Don't you see that? Alright, it didn't just happen to come out like that. Whoever wrote the problem made it, so this will cancel out. X plus 4 and x plus 4 cancel each other out. There's your 9/5, just like we said. Simple. It only takes you a couple seconds to do that. Alright, here's another one. It's kind of like this, because there's nothing that will cancel out. Some people look at it and say, oh, the z squareds cancel out. But do they? No. We've talked about this many, many times. I'm getting tired of even talking. Aren't you tired of hearing it? Me saying, do these cancel out? Why don't they cancel out? Because they're being added to something, okay? But I have to repeat that over and over again, because as many times as I repeat it, it seems like people still want to cancel these things out. So what you're going to do is you're going to factor the top and factor the bottom. So what kind of factoring do we have here? What's that fancy math word that we use for this? Trinomial, right? Trinomial factoring, okay? We mentioned that quite a bit. So we're going to factor the top, and we'll do the same thing to the bottom. Again, they rig these as well because not everything can factor. We will eventually, in another chapter, get to some things that look like this, and they won't factor. We got to figure out what else we can do with this. All right, so let's see what we can do. I'm going to go through this pretty quick. Put the z's, because z times z is z squared. Now let's look at the sign. That's what I always do. Look for this sign right here. This last, remember the first? It's FOIL method, backwards FOIL method. Okay, the first multiplies to be z squared, and the last multiplies to be negative 10. So that means one of them's got to be plus, and the other's got to be minus. And now I have a choice. I got 5 times 2, I got 2 times 5, I got 10 times 1, I got 1 times 10. All right, we just got to pick one that works. I don't know. I'm not even looking at the answer. Okay, I'm completely doing this as if I was doing this from scratch. Okay, so I'm going to try that and see if that works. Does it work? Yeah, it actually does, doesn't it? Because if I take the outside, that's negative 2z, and the inside is positive 5z, add them up, and it's positive 3z. So yeah, that does work. Again, it's just the first number that popped in my head, and I just put it down, and it happened to work. Let's do this one. Put a z and a z right here. Look right here, though. Look at this last sign. When I multiply the last two numbers together, it has to be positive. But then when I add them up, it's got to be a negative. So I have two choices. In order to multiply two numbers and get a positive answer, they both either have to both be positive or both be negative. Right? What do you think? Am I going to make them both positive? No, because when I add them together, there's no way I can get a negative if I add two positive numbers, is there? So what I'm going to do is make them both negative. So I deal with the signs first. Okay, I put the signs down there first. And now I figure out what times what is 4. Well, I got two choices. I got 2 times 2 or I got 4 times 1, right? So let's pick one. Let's just go 2 and 2. Let's see if that works. All right, so the outside would be negative 2z, the inside is negative 2z. How about that? First shot on both of them, right? Now, you may not get it the first shot every single time, but these are pretty easy. These are one of the easier trinomial factorings that you're going to do. All right, now let's see what happens. Did that help us at all? Yeah, absolutely helped us, because look, now you got two things that are multiplied, two things are multiplied. Now can I cancel stuff out? Yeah, absolutely, because this z minus 2, even though there's a minus in there, that whole parentheses is being multiplied by something else, so that means multiplication, division are inverses of each other. That means this will cancel with this right here. And what am I left with? Just z plus 5 over z minus 2. Oops, minus 2. There it is. Okay, that really, the canceling part was the easy part. It was just the factoring. You just have to know how to factor. We did that in the first test. Remember doing that? We did quite a few factorings. That was one of the easiest trinomial factorings that you're going to do. All right, let's look at the next one. Okay, here's one. It's a division problem, and you're dividing fractions. Well, do you remember how to divide fractions? We never really divide a fraction, do we? What do? We multiply by the reciprocal. We multiply the second one. So the first one stays exactly the same. All right, we never change the first one. The first one stays the same. But now, instead of dividing by this, we multiply by the reciprocal. So you put 20 over x cubed. Okay? And now you see what cancels. Now look, everything's being multiplied here, so I can cancel stuff out now. All right, there's no addition going on, so I can cancel out anything that can cancel out. Let's do the numbers first. This 4 and 20. First of all, does 4 go into 3 or 3 go into 4? No. But 4 does go into 20. 4 goes into 4 once, into 20 5 times. Let's look at this. I got an x squared and an x cubed. Well, this is x squared is like x times x, or 2x's up here. There's 3 x's on the bottom, so 2 of these x's will cancel with 2 of these x's. Everybody see what I'm doing there? So 2 of these cancels with 2 of these. I got 1 left over down here on the bottom, don't I? So I got 2 on the top, 3 on the bottom. 2 of the 2 2's, right, cancel, or the 2x squareds cancel, and I'm left with an x on the bottom. Does anything else cancel out? Nope. So let's find out what's left over. I got a 3 and a 5. What's going on with the 3 and the 5? They're being multiplied, so that's going to be 15. And then on the bottom, I just have an x. Bang. Easy as that. Shouldn't take long at all to do a problem like that. Okay, let's do another. Alright, look at this monster. Well, really, it looks crazy, but it's really not as hard as it looks because, again, they rigged this thing where these things will factor. If you look at it, you've got trinomials. You got one here, one right here. Now, this is not a trinomial, but we can still factor it, right? We did one in the beginning of this. Number 1, we factored something very similar to this. So this basically just tests your factoring skills, something that you should have been able to do from chapter 1. All right, so let's give it a shot. This is multiplication, so I don't have to flip anything. I don't have to take the reciprocal. All right, it's already multiplication. So let's do right here. So it's a trinomial. I'm going to put 2 parentheses and let's factor it. I've got a k and a k. Now this is both plus, so I'm going to put both positive right here. Now 40, it has to multiply to be 40 and add up to be 13. Well, you got a lot of choices. You got 40 times 1, you got 2 times 20, you got, what, 4 times 10. But what should you be able to kind of look at in your head? 5 and 8, right? 5 and 8 add up to 13. They multiply to be 40, so there you go. And it doesn't matter if you go 5 and 8 or 8 and 5. It doesn't make any difference. Let's do this one. Now remember I said that other problem, it doesn't get much easier than that? Well, this just did. Okay, this factoring was really, really easy because when they're both positive, that makes it really simple to factor, I think. All right, let's take a look at this, 72. And you got to get 17 when you add them up. So what multiplies to be 72 and adds up to be 17? 9 and 8, right? Okay. If you know your multiplication tables, you should be able to do that very quickly. Let's look at this thing right here. This is not a trinomial factoring. I'm not going to put 2 sets of parentheses, but there is something in common with both of these, and that would be k. So I factor out a k and find out what's left over. It's going to be k plus 9. Okay, that's simple factoring right there, just greatest common factor. One more trinomial. And we've got some minuses in here, which makes it maybe a little bit more difficult, but we can deal with that. They have to multiply. The last 2 terms have to multiply to be negative. So one's going to be positive, one's going to be negative. And you got to get negative 35. So I'm thinking 7 times 5, aren't you? And it's got to add up to be a negative 2. So I'm thinking the 7 should go with the negative, and the 5 should go with the positive. That works out nice, doesn't it? Yep, because that would be a negative 2 when I add them up. It's a negative 35 when I multiply them. Alright, that was all the hard work. Now the fun part. This is what I enjoy. Watch this. This is all being multiplied, isn't it? Even though you see some pluses in there, it's still in parentheses. So all these parentheses are being multiplied. So now I can cancel stuff out. So let's see. I got a k plus 8 here. Well, that k plus 8 cancels with this k plus 8. K plus 5 cancels out right there. Seeing this fun? K plus 9 cancels out. Anything else cancel? What about this k and this k right here? Do they cancel? No, because this k is part of a subtraction problem. So the only way you can write this, you just write a k on the top and a k minus 7 on the bottom. And that's it. Alright? Factoring. Alright, look at this one. This looks kind of like what we just did, doesn't it? But it's got a little bit of a twist. Morgan, what's the twist? It's division, right? Okay, it's division. It's not multiplication. So I'm not going to factor right now. There's also something else that's kind of weird about this. Anything else you see there that looks a little bit weird? Yeah, the 0 right there. So we could probably rewrite that, couldn't we? Just z squared minus 64. And if you look at it, z squared minus 64, what do you recognize about that? It's a what? It's a difference of two squares, right? We've mentioned that many, many, many times, haven't we? That should just be second nature to you now. All right, so let's rewrite this, and we're going to switch this thing around. Now, since I have my magical blackboard right here, look at that. See, that was quick, wasn't it? Don't you wish you could do that? And now, what we're going to do is we're going to change this division into multiplication. But what do we multiply? Multiply by the what? Reciprocal. So the z squared minus 64 goes on top. And the z squared plus 4z goes on the bottom. That was the only twist. That was the only new part of this problem compared to what we did on the other problem. Now, the rest of this is exactly the same as what we did in number 4. So let's do that. Let's do this kind of quick. So I got a z and a z. What do you got? 9 times 4, right? So 9 and 4. And then on the bottom, we already did this number on the last problem, didn't we? Z and z, 9 and 8, right? Multiply. Difference of two squares. Well, difference of two squares is nice and easy to factor. So I've got a z and a z, and I got a plus 8 and a minus 8. And on the bottom, this is just a greatest common factor. It's not a difference of two squares because it's not a difference, right? It's a sum. So I just factor out the greatest common factor. So factor out a z, and I have z plus 4. There you go. That was all the work right there. Didn't take that long. If you know how to factor, right, if you're okay with that factoring, that shouldn't take you long at all. So now, watch, bang, bang, they'll go. Bang, bang, they'll go. Z minus 8, z plus 8. Did they go? No, because they're different, aren't they? That's minus, that's a plus, so you can't cancel them out. I've seen a lot of people do that. But you can cancel this one, though, can't you? Z plus 8, z plus 8. They'll go. All right, what's left over? Z minus 8 on the top, and on the bottom is just a z. Do the z's cancel out for the 1000th time? No, because the z is being part of the subtraction problem right there. And that's how you write it, just like that. All right, this is a little different now. Do you see the big difference? Oops, that was crazy. That's right, it's because of the addition right there. All right, so now we're not just multiplying these things together. Now we have to find a common denominator. When we have fractions, we have addition. We've got to find a common denominator. So let's do that. Let's find a denominator right away. Look at 10 and 14. You may not be able to do this in your head, but do you remember what we did? Off to the side, I'll put a 10 and a 14. Let's break 10 down. That's easy. It's just 2 times 5. Break 14 down. That's easy as well. 2 times 7. And how do we figure out what the common denominator is? Let's take a look. I got a 2 here and a 2 here. So it only shows up once, though, doesn't it? In both of these columns. Remember we made a little column right here? So I got 1, 2 here, 1, 2 here. Which one do we pick? Doesn't matter. Just pick one of them, though, right? It only shows up one time. It doesn't have to show up in both places, okay? But it just has to show up one time. So I pick one of the 2's. I don't care if I circled that one or that one. Just pick one of them. Don't pick them both. What other numbers show up here in this list of numbers? A 5, so we pick one of those. There's only one of them, right? So we circle it. What else shows up? A 7, so we circle that. What do we do with those numbers that we just circled? Multiply them together. 2 times 5 is 10, times 7 is 70. That's my common denominator. If you understand that, you can do more complicated denominators than that. All you got to do is break them into its primes, go through this little procedure that we just finished doing right here, find out what numbers show up. If it shows up more than once, okay, you pick the one that it shows up the most number of times. But the 2 only showed up once here and once here, so I just picked one of those 2's. The 5 showed up. Again, it doesn't have to show up in both columns. All right, it just has to show up in one of the columns. If it shows up in both, you take the one that shows up the most number of times. So that's 70. Now, what about the x's? I have one x here and I have 2 x's here. So again, I pick the one that shows up the what? The most number of times. So I've got 1x here and I got 2 x's here, so I pick the one that shows up the most number of times, which is x squared. So that's how you find that common denominator. That's your common denominator with these 2 numbers. Now you go through that routine of finding the numerator. You have to ask yourself this question. What did you multiply this by in order to get my new denominator? What did you multiply 10 by to get to 70? You multiplied it by a 7, didn't you? Okay, so that means you multiply the bottom by a 7. What else did you multiply this by to get to this? You had to multiply x by something, didn't you? Times x. So you multiplied that by 7x. So we multiply the bottom, the denominator, by 7x, which means we're going to multiply the top by the same exact thing. Right? And that's going to give us 21x. Right? That's not that hard, is it? What about this next one? What did we multiply 14 by in order to get 70? Right, multiplied it. If you look at this, watch. See this 2 and this 7? That's the 14, right? We multiplied it by a 5 to get 70. So you multiply this by 5. Did we have to multiply the x squared by anything to get this? Not at all. Okay, so we don't have to multiply the top by x. Just multiply that by a 5 as well. 45. All right, and there's your 45, and you're done. That's it. Now you could. Now remember I said the book factored this out. They said, okay, what's in common with both of these? Well, 3 is in common, and that's a 7x plus 15 over 70x squared. But did you really have to do that? I don't think you really had to. Now, it might have been a good idea to try it, because then you could see if anything cancels out, right? Because if this 70 was divisible by 3, right, if this was a number that happened to be divisible by 3, then the 3 would have to cancel out. So that would be important to factor it out. But in this case, 3 doesn't cancel out with 70, so you could have kept it just like that if you really wanted to. And the book wrote it like this, okay? You could keep it like that as well. I would be fine either way. Alright, this looks a little bit trickier than the one we just finished doing. The one we just finished doing was a little relatively easy compared to this one. On this one we have to find a common denominator as well. But we can't go right to finding the denominator. On this one, what does it look like we might have to do with our denominators here? Factor out the denominator, or factor out these denominators. Yeah, I guess I could say that. And then it's going to make it a lot easier to find a common denominator. Do not try to find a common denominator straight from this. And I said that before when I first taught this thing and when we reviewed for the quiz. I talked about this, but still, people are trying to go straight from this to find a common denominator. I don't know what else I can tell you. Okay, you've got to watch and listen to the things I tell you, because I can see on some of the quizzes that were turned in, I can see that some of you guys didn't have a clue how to even begin this. But look at this thing. You should have a clue. If you look at this thing right there, that looks like a what? We've said it already once today. It's a difference of two squares. And look at this. We've said this several times today. What kind of thing is that? It's a trinomial, isn't it? So we do the trinomial factoring. So that's what we're going to do here. So let's rewrite the denominators as a factored product, okay? So this is a difference of two squares. You should know how to do that. They're both the same except one's plus and one's minus, and you got 4 and 4. Okay, so that's your common denominator. Or that's your, I shouldn't say that. It's not your common denominator. That's just a rewritten denominator, okay, in a factored form. Let's look at this. Look at the bottom here. It's a trinomial. This is an easy trinomial. About the easiest trinomial. If I could think of the easiest trinomial factoring problem ever in the world to do, it might be this problem right here. You understand why? 4 and 1. Yeah, 4 plus 1 is 5, right? So you got 4 and you got a 1. So it multiplies to be 4 and it adds up to be 5. Right? Now what we have to do is find our common denominator. We haven't even talked about finding the common denominator yet. But remember what we just did with those two columns. Remember we had those two numbers? What were those two numbers? 14 and 10, was that what it was? All right, it's the same idea. Look at it. If you want to mentally put a column right here. Look, I've got an x plus 4 and an x minus 4 over here. I got an x plus 4 and an x plus 1 over here. So let's figure out how we're going to find out our common denominator. So look at these two columns. What numbers show up? Well, I got an x plus 4 here, don't I? And I also have an x plus 4 over here. But it only shows up how many times in each column? It only shows up once, doesn't it? Once here and once here. Yeah, I know 2 times altogether, but we're just talking about in each column, how many times does it show up? It just shows up once. So I just pick one of them. I don't care which one I pick. Let's just pick that one. Okay? What other things show up here? Well, an x minus 4, right? Does it have to show up in both columns? Not at all. It just has to show up somewhere. So I've got an x minus 4. I don't have any over here, so I just pick it. So I pick an x minus 4. Right? And I've already picked one of these x plus 4, so I'm not picking that one. Right? What else shows up? X plus 1. So all 3 of those things, you know how we multiplied them all together in the other problem? We went 2 times 5 times 7. This one right here is it's the same deal. Okay? We just multiply them together. But this is actually, in a way, this is actually a little bit easier, because you don't even have to know any multiplication tables, do you? What do? you go x plus 4, x minus 4, and x plus 1. Everybody see that? It's really not that complicated. Some of you guys are just making this way too hard. You're just looking at this and saying, oh, I can't do it. I don't know why, to tell you the truth, because I've tried to simplify this as much as we possibly can. And if you're really paying attention and you understand a little bit about finding common denominators, you should be able to do this. And if you know how to factor, you definitely have to know how to factor to be able to do this. Let's ask ourselves the question that we did before. What did we do to this denominator right here? Watch this. Let's circle the whole thing. What did we do to this whole thing to get this whole denominator right here? Yeah, there's already an x plus 4. There's already an x minus 4. What's the only thing that's missing? The x plus 1, isn't it? All right, so we're just going to multiply the bottom by x plus 1. I'm not going to show that because it's going to get a little messy. If I multiply the bottom by x plus 1, I also have to multiply what? The top by an x plus 1. All right? So let's just write it like this for right now, just so you see what's going on. All right, so I multiply the bottom by an x plus 1 to get this, so I have to multiply the top by an x plus 1 to get this. Let's do the same thing over here. Let's get rid of this x'd out thing in the circle. So now we have to ask ourselves, what did we do to this? What did we multiply this by in order to get this whole big denominator right here? An x minus 4, right? Okay, because we already have an x plus 4. We already have an x plus 1. What's the only thing that's really missing? The x minus 4. So I have to multiply this by an x minus 4. I'll write this in this time. And then you multiply the top by an x minus 4. Notice what I did to that x minus 4. What did I do to it? It's very important. Put it in what? Parentheses, because when I multiply by a sum, I always want to put that in parentheses. So let's see what we get. We got a minus right here, so don't forget that minus. It's very important. So it's a minus 8, and then in parentheses, that's very important, you put an x minus 4. All right? We're almost done. All we got to do is simplify the top. So look at this x times x plus 1. I'm going to multiply it out, distribute the x. So I get x squared plus x. Over here, I got to distribute this. It's not just an 8, though. Remember I said this is very important that you put the negative there and the parentheses, and here's the reason. I've got to distribute it through, so I've got a negative 8x. Now, it's not minus 8 times 4, and it's not just minus a 4. What is it? It's a negative 8 times a negative 4. What's negative 8 times negative 4? It's a positive, what? 32, right? And that's over that whole denominator. All right, I'll tell you what, I'm not going to, just for time's sake, I'm not going to rewrite that denominator. Can we add some like terms here? Yeah, not much, but we can. All right, so it's important that you multiply all those out so you find your like terms. So I've got x squared minus 7x plus 32 over that whole denominator. And I'm too lazy to write it out, so I'll copy and paste it. There we go. And I'll tell you what, I'll put this here too, just so you don't forget about it. All right? And that's it. That's your answer. That's how I read it off, isn't it? Just like that? Yep, I think so. All right. Do we have time to do another one? I was wanting to get half of them done today. We didn't quite get there. But we'll do a little bit more of this tomorrow. And so work on that. At least the ones, here's a good idea. The ones that we did today, 1 through 7, at least try those tonight on that second worksheet that I gave you, okay, the part B. All right, so now you saw them. Now you saw me do them, but that's not enough. You can't just sit there and say, okay, I just watched him do these problems. Now I know how to do them. You have to practice them yourself, okay? So work on these yourself. That's the only way that you're going to be able to do these, if you practice them yourself. You can't just sit there and watch me. I think I gave a pretty decent explanation of these today, but just because I might have given a good explanation doesn't mean that it sinks in. All right? Make sure that you do these on your own.